Hello class, in this video we're going to go over set 2 problems that are in chapter 2 lesson 1. We have problem number 4 where it states one way to represent a function is with the table. For example, if a function has a formula y is equal to 3x, then a partial table for it might look like this. And we have x and y as our two values. We have values that are designated for x as 0, 1, 2, 3, and 4. Now, if y is equal to 3x, then for the value of x being 0, then y would be 0 because 3 times 0 would be equal to 0. Now, with the x value of 1, we would know that the y value would then be 3 because 3 times 1 is equal to 3. The value of 2, y would be equal to 6. The value of 3, the value of y would be 9. And with an x value of 4, the y value would be 12. So, we're now told to copy and complete the tables shown for the functions having these formulas. So, all we're going to do here is we're going to put the values in for y that are missing. They give us the first one. So, on our papers, we would write our formula. We have formula. And that is y is equal to x plus 5. And now we have below it a table. Okay, this is our table. And our table looks like this. We'll have the x row and the y row. And now they're giving us all the values for x. That would be 0, 1, 2, 3, and 4. They're asking for these 5 values, and they give us the first one, where if x is equal to 0, then y would be equal to 5. And we know that because we would just simply write y is equal to 0 plus 5. And we know that 0 plus 5 is going to be equal to 5. Now, for the value of x is equal to 1, we would write y is equal to, and we put in the value of 1 for x, and we add 5, as the formula states. So then y would then be equal to 6. So we would write 6 into this area here below the 1 on our table. Then we would have y is equal to the x value of 2, which is our next one. So 2 plus 5 would be equal to 7. And y is equal to, our next value is 3. So it would be 3 plus 5, and that would be equal to 8. So we would write 8. And with the y value, the x value being equal to 4, so we put 4 in the place of x plus 5, and that would be equal to 9. So we've completed this particular exercise A, and we have shown the values of 6, 7, 8, and 9 to be the answers to this particular one. And you would do that throughout. They get a little bit harder. There are mathematical functions which you should know. It's just a matter of putting the value in for x and then getting the output or the value of y. And let's now turn to number 5. I'm going to erase my board here. I like my little eraser. I just go ahead, it cleans it up real nice. Okay, so what's number 5? 5 is to find the value of a complicated expression that includes x. It is helpful to replace each x with parentheses first and then write the number for x in each. For example, suppose a function has the formula y is equal to 2x squared minus x plus 3. To find the value of y, if x is equal to 5, we first write, so we can use this method. You can just put in the parentheses, and then you would put in the value for the parentheses. Okay, so let's write this out. We have y is equal to, it was 2x squared, so it's going to be 2 times parentheses something squared. Let's not forget our square there. Minus, where x goes, we have the parentheses, okay, plus 3. And this is an exercise just to get you to use the parentheses, understanding that x in itself is being factored, or it's a factor within these expressions. And we have here these terms where 2x squared, we now have the parentheses, it's being multiplied 2 times x squared. So we just have to put in this value here. We have to find out what value would be for x. Oh, we don't have to find, we're going to be given those values, or we would create those values. But nonetheless, we're representing this unknown with a parentheses. Okay, and then we would just simply go in and substitute as they showed here. We had 5 that's being used, so we would put in 5. And since 5 is the value for x, wherever you find an x, you have to put in that value of 5. In this case, it was these two areas here, these two parentheses. So now we have 2 times 5 squared minus 5 plus 3. And if we further simplified that, we would find out that this is going to be, let's go ahead and do this math. What do we do first? Well, we're going to have to square, right? Order of operations. We're dealing with the parentheses, but in this case, the parentheses is just the value. But we're dealing with parentheses, and in particular, the exponent. So that would be 2 times 5 times 5, which would be 2 times now 25. And now we just simply have 5 here, and we have 3. And if we did our multiplication again, they don't really show that step, but we would then multiply left to right, and that would be 50 minus 5 plus 3. So that means our value would be 48, okay? So now knowing this, says copy the tables for the following functions and use this method to complete them. So we have here y is equal to 1 plus 3x squared. So if we were to rewrite that, what would we do? We'd say y is equal to 1 plus 3 times some kind of number there, right? Parentheses, and that would be squared. Then we would follow the table that they're giving us. There's a value of 2. Well, if we did 2, it would be 2 squared, right? And 2 squared is 4. And 3 times 4 would then be 12 plus 1, so that's how they got 13. So now you have to go in and put in the values of 3, of 4, of 5, and again give the y value on the table. And then for the second formula, you would do the same. You would have to write that formula out. In this case, it would have been y is equal to, let's see, 2 times parentheses cubed, that parentheses is where we'll put our values in, and subtract parentheses squared. Okay, so the x value would go in here, and we have another set of values for x, 2, 3, 4, and 5. So you would go ahead and do that. So that's how you do number 5. And they're fairly simple exercises. All of these exercises are going to ultimately build up to bigger exercises where we're going to use these simple steps that we're using now to solve bigger problems. These may seem somewhat simple. It's just really a lot of math, but it's understanding where values go as it relates to the formula. And how do we treat the table in that respect? Okay. Now in this one, we're asked to guess a formula for the function being represented by each of these tables. So you should begin each formula with y is equal to. Now, here we do look at this and we have to figure it out. There's a little bit of guesswork that might go in here. It's almost like a puzzle. Okay, so it's going to challenge you to think, to look at what's the relationship between each of these sets of numbers. And we'll go ahead and do this first one. Let me get my pencil back. Now the first one gives us a table of, we have a table of x and y with 2 rows, and we have value 1, 2, 3, 4, 5, and we now have y values of 6, 12, 18, 24, and 30. So now the question is, what formula is represented by this table. And if we start looking at the value here, we could come up with at least two different things that we could deduce from 1 and 6. We could say that x plus 5, right, in this case, is equal to y, because we can say that we put a value of 1 and we add 5 and we would have gotten 6. Now the question is, does that work here? And we would say, no, it doesn't, because if we would have put in 2, then this value would have been 7. So this doesn't work, this x plus 5. Now what other expression might we say here? Well, we could certainly say y is equal to 6 times x, right? Because when we multiply 1, we get 6. So what happens when we do it over here? Well, we multiply x by 6, that would be 2, we'd get 12. Hey, it worked. It worked here, didn't it? Let's try it over here. When we put in x, the x value of 3, we get 18. Hey, it worked. And we try it with 4. 6 times 4 is 24, and 6 times 5 is 30. So we have found our formula. Our formula is y is equal to 6x. So really the safest and the simplest way to do this is to look at the value, the relationship between the first one, and try to come up with one that actually works, and then test it with the others. And if it doesn't, then you look for another. It's a little bit tricky, and sometimes you're going to have to look at maybe the first two. It does get a little bit challenging, but that's how we determine what the function for the table is.